Okay, let's talk about now for the last video of the morning, the difference between a pure substance and a mixture. Okay, so you can see here we've got in the picture 4 pure substances, and there are various types of compounds. I know you don't know much about compounds yet, but or atoms, elements. One of them is. But you'll learn more and more as things go on. But for right now, let's just concentrate on the pure substance mixture thing. Okay, so most of the things that you see in the world are mixtures. In fact, it takes work to get a pure substance out of a mixture. It's like, I don't know, if you have a jar of change, right, that's a mixture of pennies and nickels and quarters and things like that. And if you wanted to only get the dimes out, you would have to do some work to actually extract those dimes from the rest of the change bucket. Okay, so that's what somebody has done previous, not myself, to me, demonstrating this, so I could actually have pure copper, pure sodium chloride, pure sucrose, which is essentially table sugar. This is essentially table salt, and pure oleic acid, which is the major component of corn oil. So we also have another substance here, deionized water, which is pure water. Okay, so those are all pure substances. And let's do the reverse, so let's put these things back into a mixture. Okay, so let's go about and look at the different kinds of mixtures you can get from these substances. So let's put some of this copper shot into here. Okay, so you can see we've got it in a beaker now. Hopefully you can see that it's still on camera. And now we'll put some deionized water in there. Okay, so now we've got a mixture of those 2 pure substances, copper and deionized water. Okay, so here's the mixture of those 2 substances. Hopefully you can see, well, what we say is the copper did not dissolve into the water. So we've got a mixture, but it's a heterogeneous mixture. Okay, so hopefully you can see that. Okay, so let's do the same thing with sodium chloride and water. Okay, so let's pour a little bit of the sodium chloride. So remember, this is just regular table salt. This is actually pure stuff that I got from the chemical company. So pour a little bit of water in there. And then we'll mix it up. And you probably know what's going to happen from doing this in your daily life. Put some more water in there. So you can see, hopefully now, so this is an ionic compound, and this is typical of ionic compounds. Some ionic compounds won't do this, and we'll talk about those later when we get to the solubility chapter. But you can see there, hopefully, that we've made a mixture that looks quite different than the 2 components individually. Okay, so I guess it looks very much like the pure water, which is the solvent, which you'll learn about later, but it looks very little like sodium chloride. But if I were to taste it, it would taste a lot like sodium chloride. So mixtures have the components or properties of both of the components of that mixture. This actually is different than this mixture, hopefully you can see, because you can't see the sodium chloride particles anymore in there. But you know they're in there because they've got the properties are still being shown, right? See, you can still see the copper particles here. Okay, so this we call a solution or a homogeneous mixture. So in chemistry we call homogeneous mixtures solutions. So heterogeneous mixture, homogeneous mixture. Okay, so this was an ionic compound. Now let's do a covalent compound like sucrose. Okay, so remember we said this is like pure table sugar. So let's go ahead and do the same experiment with it. Oh, and by the way, if you are wondering if this is a physical or a chemical change, all mixing of things is just a physical change. Once it starts catching on fire or bubbling or something like that, reacting, then you can call it a chemical change, okay? And there's some videos on there somewhere about physical and chemical changes. So you can see this is a covalent compound, and we'll try to mix it up. So table sugar, I'm sure you guys know what's going to happen. Put a little bit more water in there. So even though the other one was an ionic compound and this is a covalent compound, they still exhibit that same property of being what we call soluble in water. And that's due to the chemical structure of them. They're both molecular solids that are polar. So sucrose is very polar and water is very polar. Both molecular solids. You'll learn more about that later. But you can see, right, we mix them up, right? And again, just like this one, you can't really see the sugar anymore. You can't see it at all. But if I were to taste it, it would be sweet. So it still has that property of sugar. So we know this is a mixture, but since we can't see those sugar particles anymore, we call it a homogeneous mixture. And again, homogeneous mixtures we call solutions in chemistry. Okay? So we've got a heterogeneous mixture when we mixed copper and water, a homogeneous mixture or solution when we mix sodium chloride, which is an ionic compound, and a homogeneous mixture when we mix sucrose, or a solution when we mix sucrose. So let's see what happens when we mix oleic acid. So oleic acid is also a covalent or molecular compound. So very much like sucrose, very much like water. So if we were to just compare it with what happened to sucrose, we would expect it to dissolve as well. But what happens, here, let's show you. Put the oleic acid in. So this is essentially the major component of corn oil, or a major component of corn oil. And let's mix it with water and see what happens. So we made a mixture, but hopefully you guys can see that it's not a homogeneous mixture. Right? The oleic acid has made a layer. Here, let me get this stir stick out of there. Has made a layer on top of the water. Okay, so that's still a mixture, but it's a homogeneous or a heterogeneous mixture, sorry. Okay, and the reason they don't dissolve in each other is, unlike sucrose, oleic acid, so oleic acid is a non-polar compound, sucrose is a polar compound. So, well, why does sucrose dissolve in water? Well, water is polar, and things that look very much like other things dissolve in them. So there's a rule that we say like dissolves like, and if you can remember that for later, It'll really help you out. So we'll talk more about this solution stuff and like dissolves like, but the mixture part of this video is the most important for you guys who are doing chapter 1 right now. So just to rehash, right? Heterogeneous mixture, right? So you can still see the different components of the mixture. Homogeneous mixture, heterogeneous mixture. So remember, mixtures, all 4 of them, still contain properties of both of the things in the mixture. Both of these homogeneous mixtures or homogeneous mixtures we call solutions in chemistry, okay? And the reason that they've dissolved is because of 2 different types of properties that these compounds inherently have. Sodium chloride makes ions which dissolve into water, and sucrose itself is polar, so it dissolves into a polar covalent compound. Okay, so hopefully that helps. Let me know if you guys need any more explanation on this subject. Okay, have a good morning.